In this video, we're going to demonstrate using the pressure drop head loss function of the PPI Building and Construction Division Plastic Pipe Design Calculator. The example we'll use for this demonstration will be a commercial hydronic system. Before I get started with my piping selection, before beginning this demonstration, we should point out that we can adjust our working units on the left. The default is inch-pound US customary units, but if we prefer, we can always switch over to metric SI units, and that will change our flow rate from gallons to minute to liters per minute, length of pipe from feet to meters, etc. For this example, we'll stick with inch-pound US units. In this example, we're going to be working with PPRCT pipe with a fiber core layer. I've selected that. This pipe is going to be metric dimensioned outside diameters according to ASTM F2389, the standard for the pipe. And I'm going to select SDR11 pipe. That's the wall type. And the manufacturer says that SDR11 pipe will give me the pressure rating that I need for this project. Now, in the beginning, I know how many gallons per minute flow rate I need to circulate through this building. I don't know exactly what pipe size is going to work, but I'm going to estimate that 75 millimeter pipe will be appropriate. And to confirm that I've selected the right pipe material, you can see the image of PPRCT pipe showing here. And if I want to read more information about PPRCT pipe, I can click this blue link, and that'll take me to the PPI webpage all about that pipe material. So in this example, this commercial system needs to circulate 75 gallons per minute. That will provide approximately 750,000 BTUs per hour to this commercial hydronic system. The length of the pipe in this example is 150 feet long. And the fluid in this example is going to be water with 20% propylene glycol antifreeze added that will provide freeze protection in this climate in case of a power outage. Because this is a hydronic heating system, I need to enter the average fluid temperature between supply and return. And in this case, this system needs 170 degree Fahrenheit supply temperature with a 20 degree Fahrenheit temperature drop at maximum demand. That means our average fluid temperature will be 160 degrees Fahrenheit. So I've entered that. This system will include some fittings. The pressure drop through the fittings is not built into the calculator, so we'll have to enter that manually. For this piping loop, we're going to have 6 couplings, and each of those couplings is equivalent to 2 feet length of pipe according to the manufacturer. The system will also have 4 elbows, and each elbow is equivalent to 4 feet of pipe length according to the manufacturer. So I manually enter that information, and then I hit the blue calculate button to get my results. And down below we can see our results. Our pressure drop, it's actually quite low, only 3 psi pressure drop, which is equivalent to 6.9 feet of water head loss. And the velocity inside this pipe is just 5.4 feet per second, which is well within the range of capability of PPRCT pipe with hot water flowing through it. To see how these results were calculated, I can click on where it says Calculation Details, and that will open up the window showing all the formulas that were used for this calculation. To share these results, I have a few options. If I want to print them, I can hit the print button, and that'll open up a print window. I could send the results to my regular paper printer. If I want to save these results as a PDF file, I can select Adobe PDF and print the results that way. But I'm not going to do that here. I could also email the results directly to myself or my customer. If you select the email function, then just type in the recipient's email address and hit send, and they'll receive the full printout of what you've selected and the calculated results. After you're done using this function, please take 2 minutes to take our quick survey and give us results on how you like this calculator and any suggestions for improving it. Thanks for watching this video on using the pressure drop head loss function of the PPI Plastic Pipe Design Calculator.